Hello, and welcome to my video, lesson 5.6 on properties of linear relations. Linear relations are the ones that have straight lines when plotted on a graph. So which of the following are linear? And we're going to ask that question for a bunch of different versions of this. But here on a graph, ones that are straight lines, hopefully you can see this one is linear, this one is not. The first one is straight, the second one is obviously curved. Okay, continuing on, linear functions are always fit the slope-intercept form. So y equals mx plus b. So they possibly might need to be rearranged to fit that form, but they always will fit that form. So which of the following is linear? Well, this one fits. This one has a squared, therefore it's not. If it's any degree other than 1, meaning x to the exponent 1 works, but x to the exponent 1/2, x to the exponent 2, x to the exponent 20, all do not work. Any degree other than x to the exponent 1 or x to the exponent 0 does not work. So let's keep going. So those are equations, how to tell the difference there. What about a table of values? So table of values, the ratio of the change in y over change in x has to be constant between every set of points. So the first one is going to be nice and easy. So what is happening here is plus 1, plus 1, plus 1. What is happening here? Plus 3, plus 3, plus 3. So the ratio is 3 over 1. Rise over run. Or change in y over change in x. So 3 over 1, so it's 3, and that's true for every single one of these sets. Okay? So make sure that you do that part. Okay? So watch this. Here we have plus 1, plus 1, plus 1. So far so good. But here, plus 3, plus 6, plus 12. And you're like, hold on a second, but we're multiplying by 2 everywhere. Isn't that allowed? It's the same multiplication every time, yes, but it's not the same adding every time. You have to make sure adding or subtracting is the same every time. So the first one is 3 over 1, 3 over 1, let's do it here, 6 over 1, 12 over 1, like that. All right? Okay, let's keep going to the next one here. Here we have plus 2, plus 2, plus 1. Okay, so be careful here. This is plus 4, plus 4, plus 2. So just be careful. It's 4 over 2, 4 over 2, and 2 over 1. Keep in mind that these each simplify to 2. Since they all simplify to the same thing, this is linear. This one's not, this one is. Continuing on, we have straight lines and horizontal straight lines, vertical and horizontal straight lines. So vertical lines are given by this equation where x equals some number. Horizontal lines are when y equals some number. So just keep that in mind. Those do count as linear relations, not necessarily linear functions, okay? So, yeah, so here they are. Here's a bunch of examples. You should be able to draw them. Just before we do that, y equals mx plus b. The m is the slope. The b is the y-intercept, and this is going to be a focus of the next topic as well as the next unit a lot more. But this is something you have looked at from Math 9. So if you don't remember that, go back to the Math 9 YouTube playlist for that. But you should be able to draw them roughly by hand. I will say that we can also use our calculator to draw these. So -2, I'm just going to do the first one. No, I'm going to do just this squared one in my calculator, because that you may not know how to do. And if you don't, that's okay, because it's actually more of a Math 20-1 or 20-2 concept. So if you don't remember that, that's okay, not a problem. So this would look more like this. All right. So is that a linear function? No. Okay. This one, keep in mind you got your y-intercept at positive 6 and is decreasing by negative 2. So this is a linear function. This one here, we've got x equals 2, so it's here, and x equals 2 all the way up and all the way down. So this is actually, I'm just going to go like this, also a linear function. Y equals negative 4, if we place that on and we draw that across, y equals negative 4 is always there with any value of x, so that is also a linear, well, they're all three linear relations. Okay, here are a bunch of different examples. I'm going to actually just zoom out just a tiny bit so you can see all of them at once. And I want you to label each of these as linear or nonlinear and as a function or not a function. Okay, pause the video now, try it out yourself, and see if you can get it. Okay, I'm just going to use linear and so L for linear and NL for nonlinear. I'm going to use F for a function and NF for not a function. So I'm going to use that for each of those. So this first one, A, is linear but not a function. The second one is nonlinear and not a function. How do you know something's a function? Go back to the last video to check, but basically vertical line test is what you need to do here. Okay, and it's nonlinear because it's not a straight line. This is obviously a straight line, it's linear, and it is a function because it always passes the vertical line test. This one is non-linear, but is a function because it passes the vertical line test, but it's curved. This one is linear and is a function again because it's a straight line and passes the vertical line test. Okay, looking at these last two here, Jimmy runs at a speed of 10 meters per hour. I meant to write kilometers. I mean, it's true either way, but 10 meters per hour is very slow. He's a slow turtle. Anyways, 10 kilometers per hour for 30 minutes. It's clearly a constant speed. So if you do like a displacement versus time graph, it's a straight line. So it is linear and it is a function. Actually, I'm going to write that. Linear and is a function. Okay, this next one here, a cup of coffee is filled with a cup is filled with coffee over the course of 2 minutes with a constant drip through a filter. So now it's volume versus time, but again, it's a constant drip, so the volume goes up constantly. So it's linear and is a function. All right. Yeah, so I hope this video helps you understand the basics of linear relations, and good luck.